you all for joining today. I hope you can see my exhibits. I'll be talking about resilience, sustainability's forgotten half. So just to be on the same wavelength, I'd like to give a few definitions. When I say green, and this regards the built environment, specifically buildings, I mean energy efficient and having a small environmental footprint. Resilient is long life, functional, and able to withstand hazards and continue operation. Climate mitigating is reducing the causes of atmospheric temperature rise, whereas climate adaptation is reducing the impact of atmospheric temperature rise. Nice panels. This is only sustainable if you don't have to build it twice. If you have to build it twice, it's not sustainable. There are two, in my opinion, views of the world on sustainability. One is I call the flat view of the world, and the other the round view. In the flat view of the world, really the core is climate. Climate is part of green, which has been equated in many circles to mean sustainable, and resilient is a subset inside of that. I believe a better view of the world is to look at resilient and green as two independent circles with the definition I gave earlier. And really the space, the overlapping space, is what I define as sustainable. Climate mitigation is a subset of green, whereas climate adaptation is a subset of resilient. And really the best view is to the overlap area of all four of these circles is what I would call sustainable. So we've been seeing in recent year much discussion on for buildings race to zero, net zero, and zero carbon buildings. So, and some people are actually saying, we need to achieve these at any cost. So I ask, how sustainable is a race to zero that is blind to resilience? Because this is not the net to zero that we want. In fact, I always pose the question, what is the carbon footprint of disaster? And I believe it's much more than just the carbon footprint of rebuilding the destroyed building asset. It involves all the steps from before the disaster, during the disaster, and after the disaster, the preparation, the evacuation, the response and recovery, the temporary housing. And I haven't been able to put a number on it yet, but perhaps MIT can help me, because I think it may be at least twice the footprint of the building itself. So what is more sustainable? A whatever it costs, net zero that may sacrifice resilience, or a simultaneously reduction in carbon and increase in resilience that will require resilient construction and materials, and may involve an investment of carbon in resilience. I've come to think of carbon as a currency that should be invested wisely, and investing it in a long-term asset that will last is a wise investment. Perhaps investing it in a discretionary consumption item is not so wise. In the traditional definition, we say that hazard and a vulnerable asset, with the emphasis being on the hazard, creates a natural disaster. I disagree with this kind of terminology of natural disasters, because I think a better definition is to say that hazard plus vulnerable asset, with the emphasis on the vulnerable asset, creates a development disaster. And if we want to manage this, we need to focus on what we control more, which is the asset rather than the hazard. So what makes an asset resilient or vulnerable? If we put it kind of on a scale of intensity, if we are building below the hazard level, it's vulnerable. If we are building above the hazard level, it is resilient. And what makes a building resilient? Two things. The first is physical integrity, the ability to withstand the hazard. And the second is operational continuity, the ability to continue functioning after the hazard event. When we talk about hazards, insurance information shows that over 85% of the losses are due to four major hazard categories. wind, water, fire, and geoseismic. And if we can focus on being above the hazards on those four, we will pretty much have accomplished creating resilience. I like to draw a parallel from the commercial aviation industry that a few years ago celebrated its centennial, because for the first quarter of its history, it was quite disaster prone. In fact, the stewardesses had to be registered nurses to administer care to the passengers. Why? Because basically planes in that period were designed to only fly below the hazards, or as they call it in the industry, below the weather. And until they built planes that could fly above the weather, we could not have today a resilient and a sustainable commercial aviation industry. One of my favorite clips comes from the film Aviator that filmed back, I think, in 2004. It involves Howard Hughes speaking to the president of TWA, which he had bought at that time. And they're talking about the next plane they want Boeing to design and build for them. So I'd like to share with you that 20-second clip.
Draw 50 seats, with a ceiling of 12,000 feet. 20,000. Think about it, Jack. What does 20,000 feet give you? Less turbulence. I guess it's above the weather. Jack, we want to fly above the weather. Only 1% of the American population has ever set foot on a commercial airliner line. They're scared to death, Jack, and they should be.
And we should be scared to death because most buildings are flying below the weather. They're built below the hazards. And this kind of indicates my view of what below and above the hazards would mean for each of the hazard categories. For example, anything I believe built below 125 mile an hour winds, independent of location, because you have downbursts, is below the weather. And in hurricane and tornado prone areas, we need to be building above 160 miles an hour. And you can see the other kind of levels there too. As a result, we've had this kind of escalation of disaster losses, economic losses, and this only tracks catastrophes, which are defined as events above $20 million, and doesn't even show last year, which was a 200 million loss a year. So we've been escalating at probably over 6% annual growth rate on a 5-year running average. Why have we been building so many vulnerable assets? Well, I have identified 5 drivers that date back to the 19th century with the start of urbanization, as we built denser communities, often just using the same standards, not increasing the standards. Then we had in the 20th century what I call coastalization, which is not just building closer to the coastlines, but also in general on more hazard-prone areas and locations, floodplains, the more tornado and hurricane-prone parts of the country, et cetera. Then in the kind of mid to late 20th century, we started believing more in our equations, perhaps, and reducing the margins of safety, reducing the size of components, reducing the safety margin for the sake of economy, often called efficiency. And after that, we focused consumers more on cosmetics instead of the substance of their homes and buildings, on the bathrooms and the kitchens, rather than what's behind the wall. And finally, on top of that, we have today climate. But my view is that even if we didn't have climate, all the other 4 factors have brought us to the edge, and climate will essentially push us over faster. What are the 3 big excuses that I hear? One is that we can't do it. And my answer to that is innovate. And in the building sector, in fact, I believe we have most of the answers and the solutions to building resilient. We're just not using them. We're not applying them. The second is it's too expensive. And my answer to that is go down the cost and learning curve, as many other industries have, because always the first are the more expensive. And if we can standardize, and that means also standardizing our codes across the country and go down the learning curve and train the skilled labor and so forth, we can build less expensive and resilient houses. And the final excuse that one hears is consumers won't buy. And I disagree with that, because I think if consumers experience the comfort and the peace of mind of living above the hazards, they'll realize they can't live without it. Other industries have done it. This is a picture of the plane that Howard Hughes was talking about. It's the Boeing 307 Stratoliner that in the early 40s replaced the much cheaper but unsafe DC-3 and set us on a course of resilience. The other phenomena in the 60s, we had the revolution in car safety. And initially the automobile manufacturers said it couldn't be done, it would be too expensive, and consumers wouldn't buy it, and they were wrong on all three. They innovated, they went down the learning curve, and they wouldn't sell a car. They're actually marketing safety to consumers today, and consumers want it. And finally, the revolution in information technologies. Back in the 70s, the biggest computer company, IBM, stated that people really had no use for personal computers, and among others, they were proven wrong. Steve Jobs, innovated and went down the learning curve, and today we have so much capability and devices in one small smartphone. So if these industries can do it, the building industry can do it and should do it. What we have today still is a dependence on evacuation. It's like airplanes, not being resilient and giving passengers parachutes, or having enough escape routes and emergency exits, or asking people, hundreds of thousands of people, to evacuate areas that just have too many resilient homes and buildings. These are not the solutions. Where have we spent our money? In the US, if you look at the last half century or so, the size of the house per person has actually tripled. So our money has gone into bigger houses, not stronger houses, and the McMatchins even take those to more incredible levels. Whereas in Europe and Japan, houses still remain smaller, but they are stronger. In fact, I myself grew up in a 200 foot per person house, which is very, very resilient. The question then turns to how we measure resilience, because if we can't measure it, we cannot value it, we cannot incentivize it. This measure has to be robust because nature is a severe tester. We don't have a severe tester for green ratings, but we will be tested for resilience. But it cannot be so complicated that it ends up being a mini thesis on any buildings. It has to be easy to apply at the same time and standardized. And it can be a relative rating, meaning that A can be better than B, that can be better than C. And if it's consistently applied, then we can be comparing building X with building Y and building Z. Fortunately, International Finance Corp, known as IFC, which is the private sector lending arm of the World Bank, in the last 2 years has developed such an index. And I'm proud to have been a member of their team. It's called the Building Resilience Index. IFC had about a decade ago developed an index for green ratings called EDGE. That is kind of a parallel to LEED, but less complicated and less expensive to implement in the developing world. And it's been a great success. There are tens of millions of square meters of buildings that now are EDGE rated. And they wanted a rating for resilience, but they were smart enough to realize this could not be built into EDGE. It had to be a separate index, and they also needed a separate team to develop it. I led that team. I formed a group of global experts to help, and the application looks at all the 4 hazard categories, and under each has the specific category types. And there's a number of categories here that are considered default because they are present in all locations. Some of these other types are area specific, like typhoons and hurricanes. Some are more location specific, like flash flooding that depends on topography. So the program has built in this information. And basically, it's a free open source tool. It's not a black box, and anybody can know, what is in it and how it works, that incorporates geolinked hazard data. So when you put the address of the property, it will tell you what the applicable hazards are. And it's a binary. Either you have that hazard or you don't have the hazard. There's no half hazard kind of status, as there's no half pregnancy, I like to say. It also has built in the mitigation knowledge. The expert team compiled, I think it's the first of its kind in the world, a list of the global best practices. not just theoretical ones, but really the ones that have been implemented in construction in various parts of the world. And we pulled from various parts of the world. So the tool itself kind of presents a list of mitigation measures for each applicable hazard. And what the user has to do is say whether they have or do not have that measure. And their answers have to be verified by two registered engineers. So we know that they have made the correct answers about the building. The measures themselves, they fall into three categories. Some are location related, some are structure related, and some are engineering and inspection related. And the structure related may have various levels. For example, in water, there are questions as to whether you're at 3 meters, 5 meters, or 6 meters elevation from the nearby water level, which could be a sea or a lake or a river, or even the low point of a valley. BRI then, based on the information that's built in and also the building's answers, provides a rating. And basically it's a 5 scale rating. A essentially will mean that it's pretty much at a good standard code, what would be today a good code. AA would be above code. So there we pulled the best of the best and have said that, if you want to be in a AA, you need to, go above the code. The difference between AA and AA plus is that the plus includes certain operational continuity measures that I'll mention later. B would be a weak or outdated code, and NR would be a very weak code or unplanned, unpermitted development. And essentially most buildings today will be at the NR and B level. Many, I hope, of the new buildings that are being built will be at the A level, and very few will be at the AA level. And the objective is to try to move, up these. If you're a B, to see what you can do to become an A. If you're an A in the future, maybe you want to build something that's a AA or move into something that's a AA. The rating is given for each hazard category, but the overall building rating will be the lowest of the 4 ratings, which is called the weakest link principle, meaning that nature will eventually find your weakest link and destroy you there. And it also motivates buildings to work on their weakest link. So if you're a B in the first example in geoseismic, you're motivated to try to address some of the measures that you don't have and get to the A level. Obviously, an existing building has more limited opportunity to implement measures that it doesn't have, whereas a new building has a white sheet that it can work from. Just a sampling here of operational continuity measures. They include things like alternative heating, cooling, backup power, water supply, backup communication, multiple access. So there's a minimum number of these that the building needs to have at different levels to get the plus added to their rating. So is your building above the weather? Definitely, if you're a AA, you're flying comfortably well above the hazards. If you're an A, you're above the hazards, but may have some bumps occasionally. If you're a B, you're below the hazards and probably will have a pretty bumpy ride. And if you're an NR, you're kind of inviting disaster and probably will have a crash landing. Some of the criteria here, and I won't dwell on them, just to list them, for winds, and there, this is just a sampling, so there are other criteria too. For AA, you need to be reinforced concrete. For an A, above 180, and if you're below 125, you're an NR. This kind of goes through the first floor elevation, and in case of tsunami areas, it's even higher. Fire ratings for key structural elements, and also for seismic, you need to have base isolation to be a AA, bracing, which is typical in California, other seismic areas for A, and then nothing would make you an NR. So we have a choice here. Do we select a race to zero that at all costs even sacrifice resilience, which would mean an NR, or one that just preserves the current, let's say, poor state of resilience, which would be a B, or do we improve resilience to give us an A, or even more to give us a AA? And obviously there's going to be probably an investment in carbon to move up this ladder. but I consider that a wise investment for an asset that should last a century or more. Some of the implications here of this rating, and these are primarily my view on insurability. I believe that AA's will be getting discounts in insurance, whereas NRs will probably be non-insurable unless the government wants to use taxpayer money to insure them. Also, in mortgage terms, I believe that in the future, the long-term mortgages will just be available to the more resilient properties, and the less resilient, the more vulnerable properties will only see short-term lending. In terms of taxation, I feel that there should be discounts for the high resilient buildings and surcharges for the others. And in terms of value, the higher rated buildings will appreciate faster, whereas the NR buildings will lose value, and maybe even the land will be of questionable value if it's in a floodplain or too close to the shore. Here's a picture of Fort Myers Beach after Ian, where you can see, some houses survived, some didn't. I believe that if we had the ability to rate these buildings, we would, be seeing something like this, with the NRs and some of the Bs being destroyed, and the As and Bs surviving. Probably there are no AA's here. So far, IFC last year introduced the BRI in the Philippines, and has been well received, and there's a commitment to do over, I think, 1 million square meters of buildings in the next couple of years. Right now, we're testing the Caribbean, in Vietnam, and IFC is also looking at Mexico, Nigeria, India, Indonesia, Central America, Pacific Islands, and Kenya. What about the developed world? IFC is not focused there, but will make BRI available for free with the information incorporated in it for, let's say, the US, Canada, Europe, Japan, etc. And my nonprofit RAF is planning to offer training and presently looking for sponsors, and that probably will start sometime in the middle of next year. And you can get more information at resilienceindex.org. In conclusion, here are some of the considerations I'd like to leave you with. First of all, that life safety is too low a bar for building standards. Most people don't know that their house is only built, or their building's only built to give them enough time to escape, not to save the building or the house. That we need to make resilience more affordable, not make risk more affordable, because a lot of the efforts, policies are just helping make risk more affordable. That gambling with nature is a losing strategy, trying to play the odds, 100 year, 200 year, and so forth. Those numbers are all just guesses, but in the end, it's a losing strategy. That resilient solutions are better than emergency bandages. That net zero, in my opinion, is a road to disaster unless it is coupled with resilience. That disclosure and transparency in the property industry are better than what we have today. That's mostly buyer beware and finding the greater fool to buy the property. And that businesses, homes, and infrastructure are equally important, in my view. The government may think that their public building is more important, but from the homeowner's perspective, their home is more important than the public building. And if you lose your home, you don't care if the public building survive. That insurance is really intended to work for residual risk, and does not really work when too much structural risk is involved. And finally, that we need to make resilient development more profitable, because still today, vulnerable development is, I like to say, profitable, is legal, and most people don't know the difference. That's why we continue to have so much of it. Some of you probably have read my book. It's available in English, Spanish, and as an audiobook, and you can get more information on buildingresilient.com. Thank you very much. Back to you.
All right. Thank you very much, Aris, for this enlightening presentation and for sharing your insight about building resilience and building resilience index and all these innovations that we can include to make our community more resilient. Before moving on to the next presentation, I just want to mention that please pose your questions in the Q&A chat box, and please keep the questions coming. We will address and discuss the questions after the second presentation. With that, I'm going to hand it over to Bensu. Bensu, the stage is yours.